In number 35, it says a new car costs $35,000 and depreciates at a rate of 26% per year. How much will the car be worth in 5 years? So for this one, I'm using this formula y equals a times 1 minus r raised to the t. And this is just an exponential decay model where we're fixed into a certain time slot. And that's what I want to use here because it's per year. So basically what I have here is the initial amount, which is A, that's the 35,000. 1 minus R is the rate, and in this case it's the 26%. I always express that as a decimal, so 0.26. And then T is the time, and I just have to make sure my units match here. This is per year, and this is in years, so I plug a 5 in for time. And really that's it. I just have to plug this into my calculator and be careful in terms of order of operations. Make sure you start inside the parentheses and do the 1 minus the 0.26 first. That gives me a 0.74, then raise it to the 5th power, then multiply by the 35,000. Okay, so the order of operations is the only real place that you can make a major mistake here. Just make sure you start inside parentheses, then you do the exponent, and then multiply. And it looks like you get about $7,766.52. That's it. Next, it says to show whether each statement is true or false. And really, we're just going to use our identities here. So I look for which identities I'd be able to use in this first one. The one that should stick out is this numerator, the sine squared plus cosine squared. That's one of my Pythagorean identities. Sine squared plus cosine squared equals 1. So what I have is 1 over the cosine of theta. And now I just look at cosine of theta. Well, cosine of theta is 1 over the cosine of theta is the same thing as the secant of theta. So what I have is secant of theta equals cosecant of theta. And so I run into a statement that couldn't possibly be true. I know that these are not equal to each other. So now I know that this one is false. And again, the key here in the directions is the fact that it says to show your work, which means just writing down true or false will not get you credit for a question like this. You have to show why it's true or false. And I've shown that by showing a contradictory statement. Okay? I do the same thing in the next one. For the next one, I see right away that I've got cosecant here. And cosecant, it folds right in line with sine. The cosecant is 1 over the sine of theta. So now I have 1 over the sine of theta times the cosine of theta. And I just want to know if this equals cotangent of theta. And now from here, I can just treat this as cosine over 1. So when I multiply this, it gives me the fraction cosine of theta over the sine of theta. And now one of my identities tells me that cosine of theta over sine of theta is actually the same thing as cotangent of theta. And so what I've done is I've shown that each of these sides is equal to one another. And that's typically what I want to do. I just want to manipulate one side until I can try to get it to match the other side. And so I find out that this one is true. Okay, and that's it. For this one, remember secant is basically the cosine flipped. And so if you think about like just a cosine of, let's say, like 0 degrees, a cosine of 0 degrees, or 0 pi, whatever you want to call it, is going to be equal to 1, which means if I were to flip it, this guy for 0 degrees would also equal 1. And the only one that has a value of 1 at 0 degrees is right here. It's letter B. Okay? And that's the easiest way to remember that the secant looks like that, is because I see this value right here. It's 1, and it opens up instead of down. Remember, my cosine would be this instead. All right? And really, the secant is just the reverse. It's taking each of those things and flipping it. Okay? So that one is letter B. The cosecant then is just like sine. And again, my sine function looks like this. And so it's my sine function flipped, so A is the cosecant. The tangent, again, I could start plugging in values of tangent to match this thing up. If I plug in 0, I get a 0 out. If I plug in something like a pi over 4, I get a 1 out, so I can see that it's this guy right here. It couldn't be this one because this one is undefined here at 0. And so just start plugging in some values and it should be easy. Really, you should have these memorized. And then the cotangent is just the reverse of that. If I take each of these values and flip it, see here, this was tangent, but if I flip that, it gives me cotangent. If I flip this one, it gives me cotangent. So the cotangent here is letter D. And that's it. Those were some of those things that we should just have committed to memory. All right? For these next couple, we're going to use our unit circle. So for this one, it says to find the cosine of 585 degrees. And I just count counterclockwise around my circle. See, this would be 360 degrees would bring me to here. If I'm at 360 degrees and I need to get to 585 degrees, well, it's just a little bit of subtraction, really. I have to go another 225 degrees. So right here, I went around and got 360, and now I keep going another 225 degrees. Lands me right here. So I'm looking at this value. And I want cosine. Cosine is the x value on my unit circle. That's a negative root 2 over 2. And that's it. I'm just counting around the unit circle to that angle. All right? For this one, the sine of negative 4 pi over 3, what I want to do is I want to count basically 4/3 pi in the negative direction. So this would bring me to pi. And then I need to go another 1/3 pi. And 1/3 pi would bring me to here. The other thing you can do is you convert this to degrees if you're more comfortable with that. But now I look at the y value. So that's going to be root 3 over 2. Okay? And that's it. The other thing you can do is just remember that if you go to like sine of 4/3 pi, which is right here, the sine of negative 4/3 pi is the opposite. Okay, so that one's a negative root 3 over 2. Mine would be a positive root 3 over 2. And then the last one, the cosecant. Remember, cosecant deals with my sine. Okay, sine and cosecant are related. So if I go 4 pi over 3, so I go to 4 pi over 3, which brings me to here. My sine of 4 pi over 3 is a negative root 3 over 2. So the cosecant, I would just flip that, and it would be a negative 2 over root 3, which of course I have to rationalize this denominator by multiplying by root 3 over root 3. And so I find out that my final answer is a negative 2 root 3 over 3. And that's it. That's how I find those exact values. If I look at the next one, again, I'm just plugging some of these values in. So it gives me 2 times the sine of pi over 4. So I go back up to my unit circle. I find pi over 4. And it looks like pi over 4 is right here. So my sine is root 2 over 2. So this becomes a root 2 over 2. And then it asks for cosecant of pi over 6. So I go to pi over 6. Cosecant is my sine flipped. So I take my sine value and flip it. That would be 2 over 1. This one's going to give me a 2. And now it's just a matter of multiplying this out. I could cancel out these guys, and that's going to just leave me with 2 root 2, and that's it. Okay, so I'm just finding these values on my unit circle and plugging them in. If I look at the next one, I want the cosine of 60 degrees. So I'm going to go over to cosine of 60 degrees. So I find 60 degrees, and I find my cosine is 1/2. And then I also need sine of 150 degrees. If I go 150 degrees, find the sine value. There it is. It's also 1/2. So what I have here is 1/2 times 1/2, which is going to give me a 1/4. And that's it. I'm just looking these values up on the unit circle and plugging them in. In this last one, I want to use Pascal's triangle in order to expand the binomial. And if you remember, Pascal's triangle is this guy. It follows this kind of neat pattern where I add the values that are next to one another to come up with the value that's below. And this one I want to the 5th power, so I need to take it out to at least this row as I look at this thing. Because when I look at this, this is like the 0 power, the 1st power, the 2nd power, the 3rd power, the 4th power, and the 5th power. Okay? And really these are going to be my coefficients in terms of expanding this thing out. And so my initial setup is this. I write down these coefficients. And now I fill in my A and my B values. Since this is to the fifth, I do a to the fifth and I count down. And then a to the 0, I don't write an a value. The b values, I do the same thing, but I go in the reverse order. So this is b to the 5th, and then to the 4th. And then no b value at all because it's b to the 0. And then I just slap plus signs in between. All right, so this is my initial setup. All right, this is going to be my expanded version. I now just have to substitute in. See, the generic form of this thing is when I do a plus b raised to some power. And in this case, it's the 5th power, so I use this setup. But instead of a, what I really have here is a 2x. And instead of b, what I really have is a negative 3. And so I just substitute those in. So right here, for the a to the 5th, I substitute in the 2x. Here, my a value, I substitute in the 2x. And for the b value, I substitute in the negative 3. And I continue to do that. I just substitute each of these values in. And now it's just a matter of plugging each of these things into my calculator, all right? And so like the first one, I have 2x raised to the 5th power. Well, 2 to the 5th power is going to give me a 32. And x to the 5th power is just x to the 5th. In the next one, I've got to do 2 to the 4th power, which gives me a 16. But then I also have to multiply it by the 5 and the negative 3, which is going to give me a negative 240 with an x to the 4th in there. All right. In the next one, I've got to do the 2 to the 3rd power, which gives me an 8. But then I have to multiply that by the 10 and also by the negative 3 squared, which gives me a 9. So that gives me a positive 720 with an x to the 3rd. The next one, I'm going to have 2 to the 2nd power, which is 4. I'm going to have negative 3 to the 3rd power, which is a negative 27. But then I have to multiply the 4 and the negative 27 with the 10. So that gives me a negative 1080, and I'll have an x to the 2nd. The next one, I've got the negative 3 to the 4th power, which gives me an 81. I have to multiply that by the 2 and by the 5. So that gives me a positive 810, and that'll have just an x in it. And then the last one, the last one I substituted in the wrong value. That should be a negative 3 to the 5th power. And when I do negative 3 to the 5th power, it gives me a negative 243. And that's it. Everything's simplified. And this was much easier than writing out 2x minus 3 5 times and having to multiply it all out. So this is my expanded version using Pascal's triangle. Okay?